Welcome back to the session on Poisson distribution. In the previous session, we just defined the Poisson distribution, mean of Poisson distribution, variance of the distribution and MGF of the Poisson distribution. Now, in this session, we shall discuss some properties of Poisson distribution. First property is the additive property or reproductive property of Poisson distribution. That is, if x1 and x2 are two random variables, both are independent random variables following the Poisson distribution with the parameters lambda 1 and lambda 2, that is x1 follows Poisson distribution with the parameter lambda, x2 lambda 1, x2 follows the Poisson distribution with parameter lambda 2, then this sum, that is x1 plus x2 follows Poisson distribution with parameter lambda 1 plus lambda 2. This is the reproductive property or the additive property of Poisson distribution. By the definition of Poisson distribution, the probability functions corresponding to x1 and x2 can be written as f1 of x is equal to e raised to minus lambda 1, lambda 1 raised to x divided by x factorial, where x varies from 0 on to 3 up to infinity. This is the probability mass function corresponding to the first case. And for this case, we have f2 of x is equal to e raised to minus lambda 2 into lambda 2 raised to x divided by x factorial. Here also x varies from 0 on to 3 up to infinity. Now, we set x as x1 plus x2. We want to find the probability function of this x1 plus x2. We put x equal to x1 plus x2. Now, the probability of x is equal to x means probability that x1 plus x2 is equal to x, where x is a positive integer from 0 to infinity. This is equal to, this can be written as probability of x1 equal to 0 and x2 is equal to x minus 0, that is x2 equal to x, or x1 equal to 1 and x2 is equal to x minus 1, or x1 equal to 2 and x2 is equal to x minus 2, or in general we can write x1 equal to r and x2 is equal to x minus r, or etc., or x1 is equal to, the last case is x1 is equal to x and x2 is equal to 0. Which is equal to summation over R varies from 0 to x, probability of x1 equal to R and x2 is equal to x minus R. That is equal to summation over R varies from 0 to x. Here probability of x1 equal to R and x2 equal to x minus R means probability of x1 equal to R into probability of x2 equal to x minus R. We can write like this because x1 and x2 are two independent random variables. That is why we write p of x1 equal to R and x2 equal to x minus R as p of x1 equal to R into p of x2 equal to x minus R. This is equal to summation over R varies from 0 to x, probability of x1 equal to R means we can write like this by using the probability mass function, that is lambda 1 raised to R into e raised to minus lambda 1 divided by R factorial into, this is corresponding to x2. Therefore, we can use this probability function, that is lambda 2 raised to R, sorry, lambda 2 raised to x minus R into e raised to minus lambda 2 divided by x minus R factorial. That is equal to summation over R varies from 0 to x. Here lambda 1 raised to R into lambda raised to lambda 2 raised to x minus R, e raised to minus lambda 1 into e raised to minus lambda 2. Therefore, we can combine these two, that is e raised to negative of lambda 1 plus lambda 2 into e raised to minus lambda, lambda 1 raised to R into lambda 2 raised to x minus R. Divided by R factorial into x minus R factorial. This is equal to e raised to, here summation for R, therefore, e raised to minus of lambda 1 plus lambda 2 can be keep as a constant because this is independent of R. Therefore, this is equal to e raised to minus of lambda 1 plus lambda 2 into summation R varies from 0 to x, lambda 1 raised to R into lambda 2 raised to x minus R divided by R factorial into x minus R factorial. We multiply in the numerator and denominator by x factorial, we get this is equal to e raised to minus of lambda 1 plus lambda 2 divided by x factorial into summation r varies from 0 to x, x factorial divided by r factorial into x minus r factorial into lambda 1 raised to r into lambda 2 raised to x minus r. That is equal to e raised to minus of lambda 1 plus lambda 2 divided by x factorial into this summation is here x factorial divided by r factorial into x minus r factorial, lambda 1 raised to r, lambda 2 raised to x minus r, which can be expressed as x choose r. This is x choose r, lambda 1 raised to r, lambda 2 raised to x minus r. Summation over r varies from 0 to x. By definition of this x factorial by r factorial and x minus r factorial is x choose r. Which is equal to e raised to minus of lambda 1 plus lambda 2 divided by x factorial into, if we expand this summation, we get this as lambda 1 plus lambda 2 raised to x. That is probability of capital X equal to small x, where capital X is our x 1 plus x 2. This is the probability function of this sum x 1 plus x 2. That is, if x 1 follows a Poisson distribution with parameter lambda 1 and x 2 follows Poisson distribution with parameter lambda 2, then x 1 plus x 2 follows a Poisson distribution with parameter lambda 1 plus lambda 2, because this is the in the format of PMF of Poisson distribution, e raised to minus lambda, lambda raised to x divided by x factorial. Here instead of lambda, here used lambda 1 plus lambda 2. That is, this is a Poisson distribution with parameter lambda 1 plus lambda 2. This is the reproductive property of Poisson distribution. This property can be generalized as if x 1, x 2 etc. x n are n independent random variables having the Poisson distribution with parameters lambda 1, lambda 2 etc., lambda n, then the sum x 1 plus x 2 plus etc. plus x n follows Poisson distribution with parameter lambda 1 plus lambda 2 plus etc. plus lambda n. This is the generalization of the previously proved property. Now, the another property is, for a Poisson distribution with the mean 1, the mean deviation about mean is 2 by e. Mean deviation about mean is 2 divided by e. Consider a random variable x having Poisson distribution with the mean 1. That is x is a Poisson variable with the mean 1. We know that for a Poisson distribution, the mean is expectation of x, which is the parameter lambda. Here the mean is 1, therefore, the parameter lambda is 1. And we can write the corresponding probability function f of x as e raised to minus lambda, lambda is here 1, lambda raised to x divided by x factorial, where x varies from 0, 1, 2, 3 up to infinity. That is f of x is e raised to minus 1 divided by x factorial. Now, by the definition, the mean deviation about mean. Mean deviation about mean is expectation of modulus of x minus mu. Mu is the mean. Here mean is the parameter lambda is equal to 1. Therefore, this is equal to expectation of modulus of x minus 1. By the definition of expectation, we can write this as this is equal to summation over all x modulus of x minus 1 into f of x, that is equal to summation over all x modulus of x minus 1 into f of x is here e raised to minus 1 divided by x factorial, which is equal to e raised to minus 1 into summation, here range of x is from 0 to infinity, modulus of x minus 1 divided by x factorial. On expansion, we get this is equal to e raised to minus 1 into modulus of 0 minus 1 divided by 0 factorial plus modulus of 1 minus 1 divided by 1 factorial plus modulus of 2 minus 1 divided by 2 factorial plus modulus of 3 minus 1 by 3 factorial plus modulus of 4 minus 1 by 4 factorial plus modulus of 5 minus 1 divided by 5 factorial plus etc., which is equal to e raised to minus 1 into here modulus of minus 1 is 1, 0 factorial is 1. Therefore, this is the first term is 1 plus here 1 minus 1 is 0, 0 by 1 factorial is again 0 plus here 2 minus 1 is 1, modulus of 1 is 1, therefore 1 by 2 factorial plus this term is 3 minus 1, modulus of 3 minus 1 is mod 2, that is 2 divided by 3 factorial plus here 3 by 4 factorial plus 4 by 5 factorial plus etc. up to infinity, which is equal to e raised to minus 1 into the mean deviation left hand side is in the left hand side mean deviation about mean, which is equal to e raised to minus 1 into 1 plus we write this 1 as 2 minus 1, 2 minus 1 divided by 2 factorial, 1 is equal to 2 minus 1 plus here we write 2 as 3 minus 1 divided by 3 factorial plus next is 3, that is 4 minus 1 divided by 4 factorial plus 5 minus 1 by 5 factorial plus etc. which is equal to e raised to minus 1 into 1 plus, we can split this 2 minus 1 by 2 factorial as 2 by 2 factorial minus 1 by 2 factorial. We take 2 by 2 factorial. This term can be split into 3 by 3 factorial minus 1 by 3 factorial. We take that 3 by 3 factorial here. From this we take 4 by 4 factorial plus etc. minus the remaining terms are 1 by 2 factorial here minus all terms are containing minus 1 by here first term is minus 1 by 2 factorial. In this term 1 by 3 factorial, in this term 1 by 4 factorial plus etc. This is equal to e raised to minus 1 into, here 2 by 2 factorial means 2 by 1 into 2, 2 cancelled, therefore 1 by 1, that is 1. 1 means 1 by 1 factorial. In this term 3 by 3 factorial means 3 by 3 factorial is equal to 3 by 1 into 2 into 3, that is 3 and 3 cancelled, the remaining terms are 1 by 2 factorial. Similarly, in the next term we will get 1 by 3 factorial and so on. Therefore, this is our e raised to 1 minus this is e minus 2. which is equal to e raised to minus 1 into e minus e is 0, minus of minus 2 is plus 2, that is 2 by e. Mean deviation about the mean for a Poisson distribution with the mean 1 is 2 by e. The next property is if x is a discrete random variable having Poisson distribution with parameter lambda, then probability of x is even, which is equal to 1 by 2 into 1 plus e raised to minus 2 lambda. By definition, we have f of x equal to e raised to minus lambda, lambda raised to x divided by x factorial, where x varies from 0 on 2, 3 up to infinity. Now, probability of x is even means p of x is equal to 0 or 2 or 3 etc. not 3, 4 or etc., which is equal to p of x is equal to 0 plus p of x is equal to 2 plus p of x is equal to 4 plus etc. That is f of 0 plus f of 2 plus f of 4 plus etc., which is equal to e raised to minus lambda into lambda raised to 0 divided by 0 factorial. Here we can take e raised to minus lambda as a common factor because it is independent of x. Therefore, f of 0 is e raised to minus lambda into lambda raised to 0 divided by 0 factorial plus this is lambda square by 2 factorial. This is lambda raised to 4 by 4 factorial plus etc., which is equal to e raised to minus lambda into 1 plus lambda raised to 0 is 1, 0 factorial is 1. Therefore, this is 1, this first term is 1 plus lambda square by 2 factorial plus lambda raised to 4 by 4 factorial plus etc., which is equal to e raised to minus lambda into 1 by 2 into e raised to lambda plus e raised to minus lambda. That is equal to 1 by 2 into e raised to minus lambda into e raised to lambda is e raised to 0, that is 1, plus e raised to minus lambda into e raised to minus lambda is e raised to minus 2 lambda. That is the probability that x is even is equal to 1 plus e raised to minus 2 lambda divided by 2. Now, let me conclude this session. In this session, we discussed 3 properties of Poisson distribution. Thank you for watching this class. Have a nice day.